Hello, everyone. First of all, welcome to ISTA 2020. So the topic of this presentation is data science platform with Kubeflow on Kubernetes. In short about me, I'm software engineer at Musala Soft. I'm currently active with SAP on DevOps project. In free time, I have my small AI startup. I'm also data science instructor at Brainstar. Before I have written two books for machine learning and data science. And my previous experiences include positions for machine learning engineer, data scientist, and AutoML. Okay, so let's start with the problem, the main problem. So what do we want to solve? So can we solve our data science business use cases in a consistent way by using one platform in our organization? So we want to be able to create machine learning workflows that are reliable, portable, and scalable. We want to be able to compose these workflows from independent components so that for each component we can specify specific hardware and software requirements. We then want to connect those independent components so they exchange information and they work together. We want to make things easier for our data scientists and machine learning engineers so they don't have to focus on the infrastructure too much and they can focus on solving the use case with machine learning. So after machine learning model is trained, that's not the end. We need to do lifecycle management after that. And during this entire process, there are many artifacts. And we want to version these artifacts, manage them somehow. And finally, we want to make our workflows and components reusable so that we are more efficient for future use cases. Okay, so that is the main problem, and one solution, and a popular one, is to containerize your workflow components and to use Kubeflow. And that's what we will cover now. So after the presentation, you should be able to start experimenting for making your own data science platform based on Kubeflow. The main topics are data science process, so that is on the top level. Then we will cover machine learning pipelines and workflows. And finally, we will cover infrastructure, and this is where we will mention Kubeflow. Okay, so before I start, I should mention that we have to do this in 20 minutes, so I will not speak about all the notes in all the slides. I will just focus on the main points so I can transfer more useful information. And yes, so let's try to do this in 20 minutes. So the data science process, we need some structure on top. And that's why we start with the data science process. So there is a standard, it's called CRISP-DM. It has 6 phases, and these phases branch out further into generic and specific tasks. For details, I would recommend to see the official document. I would just add that this process is very stable. It's 20 plus years old. So this is how it looks. On top, there are phases, and it branches out into generic tasks. And then each generic task branches out into specialized tasks. So let's cover the 6 phases in short. These are the phases. So business understanding, data understanding, data preparation, modeling, evaluation, and deployment. This is another image from the official document, and you can see the 6 phases on top. Below, we have in bold generic tasks, and they break into specific tasks. Okay, so in business understanding phase, first we try to understand the particular business problem and the context. In the data understanding phase, we have more generic tasks like get data, and you can see here a few more specific subtasks. Then verify data quality and some subtasks below, like syntactic checks, handling missing values, and so on. Describing the data is another generic task. Exploring the data is another generic task. And that is for this phase. I would recommend, so that I don't go through all of these in detail, I think they're pretty clear. I will just mention the generic tasks so we can keep moving and cover more information. Okay, so the next phase is data preparation. This is where we prepare the data so we can then apply machine learning in the next phase. So here, first we have to clean the data, we have to transform the data, and we have to integrate the data if we have more data sets. Then we can move to phase 4, which is the modeling phase, and where we use machine learning. We specify the problem type. Is it classification? Is it regression? Given the problem type, then we try more machine learning algorithms. So this is an empirical approach. We try more things. We select in the end the best trained model based on the performance measure. So this is where we do model selection, hyperparameter optimization, and validation. In phase 5, we do evaluation. We see is the trained machine learning model, the one we selected, is it sufficient in the context of our main business problem? Is it, yeah, I would say just that. Is it sufficient? Does it help us to solve our main business problem? And if not, then maybe we go back to previous phases. Okay, so finally we have deployment. We can deploy a trained model behind a REST API. Of course, it is not just the deployment of a trained model. We have to think also about deployment of the other software context in which the model will operate. And it is worth mentioning here that most data science platforms have one-click deployment feature. So that with a single button, you can put your trained model behind the REST API. Other open standards I would mention is the work done by NIST Big Data, the public working group. If you want to establish a structure in your company on the top level that I mentioned. Okay, so then we continue to the next layer, machine learning pipelines and workflows. So by machine learning pipeline, we mean directed as acyclic graph of operators. And by machine learning workflow, we mean that this graph now goes in some workflow manager where we manage it and execute it. So let's see a few examples very quickly. So this is how a workflow looks in Airflow, for example. I will show different tools and different ways to visualize. So this is in Airflow. We have tried before, like, I mean, in my previous work experiences, I have tried visualizing also in Neo4j, visualizing with Python package networkx. This one is not fancy, but it is useful while working in a notebook, for example, and while you construct your pipeline, it is useful to quickly see, are you connecting everything right? Of course, you can always draw it yourself, like here. And later we will also see how it is visualized in Kubeflow. Okay, so if you want to make your own data science platform and you want to create your own operators, your own, and so that you can compose your pipelines, how to get started. So I would recommend first to specialize and then to generalize incrementally over time. Okay, so we have around 10 more minutes left. So first, I would recommend to specify your focus in machine learning. And here you can see I have mentioned few decision points, branching points for splitting machine learning. So specify your focus. It is a very broad area. Also for start, specify on which data type you will work primarily and focus on that for start. Structure, and structure. So it is very important to structure your code. Avoid a messy code in notebooks. This is a popular image. It's just how it feels like managing Jupyter notebooks. So due to the interactive style of work with notebooks, we end up writing messy code in there. So try to structure that code. You can see here example. For some use case before, I have tried to find structure, like in one file, I have the data preparations. In one folder, I have all my trained models. I have one main notebook. I have other files for parameters and so on. So this is just meant to be like an example to to say that try to find structure in everything. It is important if you want to create your operators, your reusable operators, and so you can make pipelines with them. Okay, so that's about structured notebooks. Try to use reusable code and structure your code in notebooks according to the data science process. Structure also your knowledge. Be aware of the different problem types and the appropriate machine learning algorithms. This here is an example from scikit-learn. If you have structured knowledge, also there are many automation opportunities. For example, here you can see a simple example function so that you can go from a data set to a list of machine learning algorithms that are appropriate for the data set and that you can try in the modeling phase. And then with one line of code, you can get that list of algorithms. Okay, so machine learning pipeline as code. Let's continue. So as I mentioned, we have a DAG of operators. And for these operators, if you're coding them in Python, for example, they will be Python classes. So on the DAG level, you will have the operations to create your DAG, to add operators, connect operators, to execute your DAG, to visualize, serialize, and you should make everything configurable on the DAG level and on the operators level. So there are different kinds of operators that you will need. Some will be atomic and will execute some tasks from the data science process for feature engineering, machine learning algorithms, or data pre-processing, dimensionality reduction, outliers, etc. Other operators will be composite and they will be made or composed of other operators, such as the column transformer, fit transform pipeline, model selection operator, and so on. So, okay. So then we have the question, what do we do about data visualization plots? Well, you can treat those as, you can treat those as operators also. The output will be simply an image, and you can redirect that image in a user interface or else. I would suggest that you wrap existing machine learning libraries, just like everyone is doing, and on top add your own functionality. So wrap scikit-learn, TensorFlow, Keras, and many others, and on top in your classes add your new functionality. And organize your operators according to the data science process. You can learn a lot from scikit-learn. It has a very stable, abstract design, so use it when you're designing your operators. Okay, so we have 5 more minutes left, so I'll have to speed up. Split your work use notebooks for solving your business use case, but for developing your reusable operators, use a Python integrated development environment. So here you can see a comparison. I will let you read that later because the video will be recorded anyway. So I would finally recommend these 2 books. The first one is practical. It will get you started fast. The second one is theoretical if you want to go deeper later on. My previous experiences include working with Airflow. So the idea here was that we can make these Airflow tasks and we can make Airflow docs. In there, we can put a user code and we can set parameters on the doc level and on the operator level. So in the end, yeah, we connect all these tasks in a DAG and we can execute a machine learning workflow. So these are the Airflow features: scheduling, monitoring, alerting, failure recovery, logging, user-friendly web user interface, that everything is code. So your pipeline is code, which means it can be versioned. You can, it has similar concepts and features like CI/CD tools like Concourse. So Airflow is from my previous experiences, and that's how I got in that's where I come from, and and I see Kubeflow as the next step of growth or and development in that direction. Because Airflow is more like a general workflow manager, but Kubeflow is like a specialized workflow manager specifically designed for machine learning workflows. Okay, so I would also recommend that you try to learn as much as possible from existing data science platforms and to check the Gartner reports. So they do reports every year and they compare data science platforms. I will just mention RapidMiner here for the common theme of all data science platforms. So for all of them, you're creating some doc, you have some operators. These operators are organized somehow here, you can see, in a hierarchy according to the data science process. You can select an operator, set its parameters, etc. So that's the main theme, that we have these workflows of operators, and this is the main theme across all these data science platforms. RapidMiner sorry, RapidMiner here is used only as example. So let's start with Kubeflow. So it enables us to handle scalable end-to-end machine learning workflows on Kubernetes, and portable also, because everywhere you have Kubernetes and you can have Kubeflow, you can port your workflows. It is called the machine learning toolkit for Kubernetes. So concepts and terms, we have a pipeline, which is the main doc, a pipeline component, which is a Docker image with user code for one step in the pipeline. And we have a pipeline step. A pipeline step is an execution of a pipeline component. We have a run, which is an execution of a pipeline, an experiment, which is a logical group of runs, and we have artifacts and metadata. So we have 2 or 3 more minutes left, so I will have to quickly go through this. So on the right, these are meant like secondary topics, just to be mentioned, that you can have more users with Kubeflow, that you can have logging and monitoring, AutoML, notebooks, rapid experimentation, composability, because you can have independent components and you can compose workflows, portability, because you can port these workflows anywhere you have Kubernetes and Kubeflow, and scalability, because on the bottom you have Kubernetes and you can scale things. I will mention now just the topics on the left. These are like the main ones for this presentation. So this is how the central user interface for Kubeflow looks. On the left, you can manage your pipelines. With Katip, you can do hyperparameter optimization. You have the artifact store for metadata. You can create a notebook server and work in a notebook, etc. So this is how the pipelines user interface looks like. You can see here we have like a list of pipelines. This is the visualization. This is the experiments user interface. This is the general structure that you create a workflow of components, and each component is in a Docker container, which in turn is on a Kubernetes pod. And in these components, you can put machine learning tasks like data preprocessing, training, predicting, and any other from the data science process that we mentioned. So this is a short summary. So you have a user code. It can be Python code. You containerize this in a Docker image, right? So from that, you can create pipeline component from that pipeline. And then with such pipeline components, you connect them and you have a pipeline. That pipeline then can be can be compressed as one zip file, and you can share this pipeline. This is example of specification for a single component. You can specify inputs, outputs, the Docker image, the user code, and various meta information like name and description, so on. I will quickly go through a few examples for artifacts and metadata. So here we have predictions. Here we have various visualizations. Here we have model information, like type of model, training and framework, the data set that was used. We have dataset metadata. Finally, let's mention reusability. Do check the AI Hub. This is where you can share with others Kubeflow components and pipelines. In your data science organization, I would suggest you have more roles: data science management, data scientists, and data science infrastructure people. And you can see here, for example, the data scientists should be able to focus mostly on the middle level, the machine learning pipelines and workflows level, less on the data science process, and even less on infrastructure. Okay, so for further contact, feel free to contact me. And I think, yes, I think the time is up. So that is that. Okay, so thank you for the opportunity. Thanks to all the organizers, and yeah, looking forward for ISTA 2021. So bye.